Let's take a look at finding lengths of sides of triangles. But before we do that, let's review a couple of very important theorems. One theorem is called the perpendicular bisector theorem. And it says that if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. In other words, we have point X. If point X is on the perpendicular bisector of a segment, and it is, notice it's bisecting this segment and it's also perpendicular. So if X is on that perpendicular bisector, then X is equidistant from these two endpoints, making XA equal to XB. Now, knowing that, let's look at a figure. Okay. We have point W, which lies on line L. Point W is a point on the perpendicular bisector of a segment. How do I know? Because these two segments are equal, and this line is also perpendicular to segment XY. Therefore, WX is equal to WY because of the perpendicular bisector theorem. Well, I know that WX is equal to 8 3/4. Do we know what WY is? Yes, we do. Since they're both equal, WY is also equal to 8 3/4. Let's try another one. That was pretty simple. Let's look at this problem. Let's turn it around so we can see it. Now, in this case, notice what we're given. We're given that in this triangle, these two sides are equal. And we're also given that we have a right angle form. And we know the length of line segment DC, which is 8. We're being asked to find BC. What is BC equal to? There's another theorem, let's look at it, that you need to remember, and it's called the converse of the perpendicular bisector theorem. And it says that if a point is equal distance from these two endpoints of the segment, then this point is on the perpendicular bisector of the segment. In other words, if XA is equal to XB, then XY is perpendicular to line segment AB, and YA, these two segments, YA segment is congruent to YB segment. Okay? Knowing that, let's go back to our problem. Again, is this point equidistant from the endpoint? Yes, it is. This distance is 24. So therefore, we can apply the converse of the perpendicular bisector theorem to find what BC is. Well, we know that according to that theorem, these two are equal. We know that BD is equal to DC. This is equal to DC. Well, I can see that DC, we're given that DC is 8, so what's BD? BD is equal to 8. I'm going to go ahead and write 8. But what were we asked to find? BC. But I can see that BC is equal to BD plus DC, And that's equal to, substituting, BD is 8, DC is 8. We find that BC is equal to 16. Okay? Let's look at another problem. Okay, this time we're being asked to find PR. I'm going to go ahead and write this down. PR. What is PR equal to? Well, if I knew X, I could substitute in place of X and find PR. But what do I also know here? I know that, notice here, that point R, okay, point R lies on the perpendicular bisector of this segment. How do I know that? Because notice it's perpendicular. Here's my line L. And I also see that these two segments are equal. PS is equal to QS. Therefore, R lies on the perpendicular, this point lies on the perpendicular bisector. And if that's true, I know from the perpendicular bisector theorem that this point is equal distance from these two endpoints. So therefore, I can write down that RP is equal to RQ. Well, RP, I'm going to substitute 3x plus 4 for RP, and I'm going to substitute 7x plus 2 for RQ. And I'm going to solve for x. Because once I find x, then I can just plug it back in here, and I'll know what PR is equal to. Well, let's see. Remember, when we want to solve for x here, I'm going to go ahead and subtract 3x from both sides. And we're going to get 4 is equal to 4x plus 2. Okay? And then we're going to subtract 2 from both sides. And we're going to get 4x is equal to 2. And x, divide both sides by 4. And we get x is equal to 1/2. Okay, 1/2. Let's go back. Since PR is equal to 3x plus 4, PR is equal to 3x plus 4, and we found that R was equal to X was equal to 1/2. I'm just going to substitute in place of X 1/2 plus 4, and half of 3 is 1 1/2 plus 4. I find that PR is equal to 5 1/2. And that's what we set out to find, what PR was equal to.